Welcome to solverfy.
Okay, we've been asked how many optically active forms are possible for the following compound, and that is cyclohexane substituted with a methyl group and a bromine. Now, one thing to note here that basically makes this question uh, relatively simple is that this molecule contains a mirror plane of symmetry. And that means that whether we make this methyl group a wedge or a hash, and whether we make this bromine a wedge or a hash, the left-hand side of the molecule will be identical to the right-hand side of the molecule. And we can typify that, for example, by if I draw this methyl group out as instead having, well, let me just draw it a little more straight up and down so it's easier to see. Okay, we draw this methyl group as a carbon with 3 hydrogens attached. Right. We imagine this bromine, right? Bromines are just a circular atom, like so. The left-hand side of this dividing line is a mirror image of the right-hand side. And that basically means that what appear to be 2 stereocenters are still so-called asymmetric carbons or asymmetric centers to some extent. But in fact, this compound is not optically active, right? You won't get one enantiomer, right, that behaves differently than the other enantiomer. And kind of the reason for that is if we imagine, instead of talking about the mirror plane in the molecule, but just drawing the mirror image of this, for example, if we drew the mirror image of it across such a dividing line like that, right? If we assume maybe this is a wall that represents a mirror, and I'm going to draw what would appear in the mirror. We'll get the exact same thing out. And that won't change. If we make this a wedge, then this will be a wedge. If we make this a wedge, then this will be a wedge, right? But they'll still be superimposable. You could pick this up and put it right on top of that molecule, and they would be identical, right? So the answer is there are no optically active forms possible for the given compound.